All right, this looks at the language of polynomials. So a polynomial is an expression which consists of terms that have non-negative integer powers. So we're talking about stuff like a linear equation or a quadratic, so x to the power of 2, a cubic, x to the power of 3. So a lot of the equations that we've already dealt with previously is what we're looking at here. So non-negative integer, so whole number, powers of x only. Now we have a few ways to label these powers, and the one we're going to start by looking at is the degree. So the degree of a polynomial is the value of the highest power of x. So for instance, the highest power in a quadratic is 2, or the highest power in a linear is 1. So the example that's here is p of x. P of x, this notation here, this is referring to a polynomial with the value we're looking at being x. So previously we would have had y equals x cubed plus 2x squared minus 1. And we're now actually changing our notation, or how we write it, and we're now using p of x. Now in this particular example, the polynomial p of x has a highest power of 3. So 2 is less than that, so that's not included. We don't have anything else with an x. So 3 being our highest power, we would state that the degree is equal to 3. So 3 highest power, degree is equal to 3. The value of a polynomial p of x can be found for a particular value of x, let's say 3, 4, 5. You could substitute in anything. By substituting that x value into the actual polynomial expression and then evaluating. Now, what this really means with respect to our equation is saying that you could have something like p of 5. Okay, so p bracket 5 bracket, which means that anywhere you see an x, you now replace it with a 5. So 5 cubed plus 2 times 5 to the power of 2 minus 1. So 5 cubed, 125, plus 50 minus 1. Evaluate that and you'll have your solution to p of 5. You could do that with any kind of expression or any kind of value for x. Now in general, a polynomial can be written in this format here. So p of x is equal to an x to the power of n being your highest degree. From there on in, as long as you lower your power by 1, anything is possible, all the way down to having no power whatsoever, which means that you've got a constant at the end. This is normally referred to as c, and you'll have probably previously seen it in a linear equation, for instance, as mx plus c. Polynomials can be named, and we use 2 forms to name them. One refers to the degree, so the highest power we were just talking about, and the other one is just the number of terms. So for instance, the example up the top was x cubed plus 2x squared minus 1, which is 1, 2, 3 terms. All right, so that would be a 3 terms, which in this particular case refers to a trinomial. So we name it using these 2 formats. The important thing here is that you start with the number of terms and then you go to the degree. So for instance, in this first example, you should recognize that a power of 2 would be a quadratic and that we have 2 terms. So 2 terms is binomial, and then with a quadratic, or with a power of 2, we have a quadratic. So binomial, quadratic. That's a mistake, and that should be a quadratic. Part B, again, 2 terms, binomial. Power, there's an imaginary 1, we don't write it, but it exists, so linear. And then lastly, there are 3 terms, so it's trinomial with a highest power of 3, so it is a cubic, so trinomial cubic. Repeating that first one, example A, has a power of 2, so it is a quadratic, not a cubic.